How chemistry normalized a hidden risk. It didn't arrive as a warning. It arrived as routine. A chemical risk repeated so often that it stopped feeling like a risk at all. The danger never faded. It simply became so familiar that the systems built around it forgot to treat it as dangerous. At first, the reaction was treated with caution. Limits were set. Monitoring was strict. Everyone understood there was danger if boundaries were crossed. Chemistry was respected because its power was visible. That visibility was itself a form of protection. When people can see the threat, they build around it carefully. The problem begins when the threat stops being seen. To understand why this matters today, we need to look at how familiarity reshapes perception. When a reaction behaves predictably, fear fades. When it delivers consistent results, vigilance relaxes. Risk does not disappear. It becomes background. It sinks beneath the threshold of attention, not because it has been resolved, but because it has been absorbed into the texture of everyday operation, where it no longer stands out against the noise of routine. Over time, the reaction proved manageable. Incidents were rare. Controls worked. Data looked reassuring. Chemistry earned trust not through safety, but through repetition. What once demanded attention became automatic. The absence of consequences was mistaken for the absence of danger, and the longer that absence continued, the more firmly the mistake took root. As adoption spread, safeguards quietly shifted, margins narrowed, exposure increased. What was once considered exceptional became acceptable. The chemistry didn't change. The tolerance for risk did. Each adjustment was minor, each was justified by the most recent period of safe operation, and each moved the boundary slightly further from where it had originally been drawn, until the accumulated distance between the original safety margin and the current one was vast, yet invisible to anyone who had not tracked its movement from the start. This normalization happened gradually. Each small adjustment felt reasonable on its own. A slightly higher threshold, a longer operating window, a broader application. Chemistry rewarded each step with continued performance. The reward was the mechanism of the trap. Every successful expansion of tolerance appeared to confirm that the previous limit had been overly cautious, when in fact the expansion was simply consuming the margin that had been protecting the system all along. This is where the story begins. With a hidden risk that didn't grow louder, but quieter, a chemical reality that remained just as dangerous as before, yet slowly disappeared from awareness as systems learned to live comfortably beside it. As familiarity deepened, the reaction stopped triggering caution. Procedures became streamlined, training shortened, monitoring shifted from prevention to confirmation. Chemistry moved from hazard to habit. The rituals of safety that had once been practiced with genuine urgency became formalities performed without attention. The forms were still filled out. The checks were still run, but the mindset behind them had changed from vigilance to compliance. This is where early tension emerged. The risk had not diminished, but exposure increased. The reaction was used more often, in more places, by more people. Safety relied increasingly on the assumption that nothing would go wrong. That assumption was rarely stated explicitly. It didn't need to be. It was embedded in the pace of operations, the thinness of staffing, and the brevity of training. The system communicated its assumptions not through policy, but through practice. Minor incidents were absorbed without alarm. Near misses were reframed as proof of control. Each successful recovery reinforced confidence. Chemistry appeared tame because consequences were avoided just often enough. The near misses that should have been treated as warnings were instead treated as validations. The system survived, and survival was confused with safety. Over time, the system adjusted its definition of acceptable risk. Thresholds rose, buffer zones shrank. What had once required special handling became routine. Chemistry had not grown safer, the system had grown accustomed. The distinction between a reaction that is safe and a reaction that has not yet failed is subtle but critical, and it was precisely this distinction that familiarity erased. Experts studying these patterns recognized a dangerous shift. Risk was being managed by normalization rather than reduction. The reaction was still capable of harm, but it no longer commanded respect. The expertise that had once been devoted to understanding and containing the risk was gradually replaced by operational habit, and habit does not adapt when conditions change. What made this dangerous was invisibility. When risk becomes routine, it escapes scrutiny. Warnings feel unnecessary. Attention drifts. Chemistry continues behaving exactly as it always has, while perception changes around it. The chemistry is constant, the vigilance is not. And it is the gap between those two realities that creates the conditions for catastrophe. The hidden risk had not been eliminated. It had been absorbed into everyday operation where it quietly waited for conditions to align. The conflict intensified when rare failures began revealing what familiarity had hidden. Incidents that once seemed unthinkable now felt inevitable. The same chemistry, the same risk, finally intersected with conditions that controls could not absorb. The failures were not unprecedented, they were overdue. The reaction had always been capable of producing them. What had changed was that the defenses designed to prevent them had been thinned to the point of irrelevance. Investigations showed a troubling pattern. Nothing new had gone wrong. The reaction behaved exactly as designed. What failed was margin. Layers of safety removed over time had left no room for error. The system had been operating on borrowed time, and the length of that borrowing had created the illusion that the time would never run out. This buildup carried emotional weight because the warning signs had been present all along. Near misses, small deviations, temporary recoveries mistaken for proof of safety. Chemistry had been signaling risk consistently, but familiarity muted the signal. The information needed to prevent the failure had been available for years. It had simply been classified as unimportant by a system that had lost the ability to distinguish between the absence of danger and the suppression of awareness. Attempts to respond exposed how normalized the danger had become. Restoring safeguards felt excessive. Slowing processes felt impractical. The system resisted change because it had learned to live with risk instead of reducing it. The normalization had become cultural, embedded not just in procedures, but in the expectations and instincts of everyone who operated within the system. Undoing it required not just new rules, but a new relationship with the reaction itself. This was the emotional peak. The realization that danger does not need to increase to become catastrophic. It only needs to be ignored long enough. Chemistry had not grown more volatile. Awareness had grown weaker. The failure was not chemical. It was attentional. The reaction did what it had always done. The system simply stopped watching closely enough to notice when conditions crossed the line. The hidden risk was never hidden chemically. It was hidden psychologically. And once perception failed, chemistry was left alone to enforce its limits without warning. The climax arrives with a stark realization. Risk does not disappear when it becomes familiar. It becomes more dangerous. Chemistry never stopped signaling hazard. Reactions continued operating within the same constraints. What changed was attention. Repetition dulled caution. Success bred complacency. The system learned to tolerate danger instead of addressing it. The tolerance was not a decision. It was a drift. And drift is far harder to reverse than a decision because no one can point to the moment it began. This understanding reframes safety. True safety is not proven by long periods without failure. It is proven by how systems respond when vigilance fades. Chemistry demands respect, not comfort. A record of safe operation is meaningful only if the conditions that produced it are still being actively maintained, not merely assumed. The resolution lies in making risk visible again, restoring margins, treating routine reactions with the seriousness they deserve, designing systems that assume human attention will drift and compensate accordingly. The most resilient systems are not those that depend on constant vigilance, but those that remain safe even when vigilance inevitably falters. This story is not about fear, it is about awareness. The most dangerous risks are not the dramatic ones, but the normalized ones, the ones we stop noticing because they have not failed yet. Understanding how chemistry normalized a hidden risk offers a powerful lesson. Safety is not static. It must be renewed constantly, or it quietly erodes beneath success. Subscribe to join the journey. How chemistry